Lesson 8.3 is all about circles, and more specifically the equations of circles. Now remember, a circle is a set of all points in a plane that are equidistant from a given point. So if this is our point, and here is our distance, we'll say it's 3 units away. Then here is a point that's 3 units away. We'll say here's a point, here's a point, here's a point, but there are all these other points that are also 3 units away, so many of them that they actually create a curved line around that point, the circle. That's really a lopsided circle, but that's how it works. That's a circle. It's the set of the points that are equidistant from that center, or from that point. So, like I said, going over some of the terminology here, that point in the middle is what we call the center. This should be basically review. The distance, like this piece right here, that the points are away from the center, we call that distance the radius. So radius is a length or a distance wise. One thing that we maybe haven't mentioned so much yet is this line over here that lies right next to the circle. It touches the circle at one point right here. And what this line is called is the tangent line. A tangent line is any line that goes through and touches the circle at only one point. So if this were a line, we would not call it tangent because it touches at 2 points. If this were a line, we wouldn't call it tangent because it doesn't touch it at all. Only this one is considered a tangent line because it touches it once. Now there are obviously other tangent lines. There could be one over here that touches it right here once, or there could be one right here, touches it right there. Those are also tangent lines, but they can only touch the circle at one point. Now, the equation for a circle is going to be down here, this piece. We would say, in parentheses, x minus h squared plus the amount y minus k squared equals r squared. That r value is our radius, so that's our length, and these h and k, kind of like with parabolas, those are the center. H and k for a parabola were the vertex, h and k are now the center. So let's see how that looks in an example here. We want to find the equation of a circle whose center is 2, -5, and the radius is 7. Well, remember, x minus h squared plus y minus k squared equals r squared. Well, our radius is 7. So we would plug that in to this piece over here. So for writing out our equation, oops, maybe I'll kind of pull it over right over here. We plug in 7 to our r value. Well, we've also have our parenthesis values over here, and those are each squared. So an x and a y in each of those, and they're each, oops, I should say minus, not adding. They each are minus something. Okay, so what is it exactly that x is subtracting? X subtracts this value of our x here. So we'd say x minus 2 squared. Then similarly, what is y subtracting? Y is subtracting this value here, -5. So you'd have to write it like that. So in the end, if we want to simplify this equation, we would say x minus 2 quantity squared plus y, minus and minus makes a plus, or should I say minus a negative, so y plus 5 squared equals 7 squared is 49. So this is how you would want to write that equation. So how would we write the equation of a circle whose endpoints are of the diameter are 2, 8, and 2, -2? So this is a good example of when we would have to use distance and midpoints rules. So if we drew in our diameter right here, then those endpoints, one is going to be here at 2, 8, one is here at 2, -2. So remember, things we need for our circle, we need the center and we need the radius. Well, we aren't necessarily given either of those, but we can find those. We can find the center right there because that's the midpoint of our diameter. And remember, to find a midpoint, we take our two x values, 2 and 2, over 2. Take the average of them. Same thing with our two y values. 8 plus -2 is our other y value, over 2. So, in the end, our midpoint there actually comes out to, this is 4 over 2, so we'd call it just 2. 8 plus -2 is 6 over 2. 6 over 2 is 3. So this is our midpoint, which we'd also call our center. So the center is at 2, 3. Okay, now we know the center, and we just need to find the radius. Well, remember, radius is just going to be this length here, from the center to one of those points. So we'll use the point 2, 8. So we have 2, 8 to the radius, or to the center, which is 2, 3. That'll give us the distance, which is our radius. So remember our distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I use, well, I guess in this case I use this as my x2, y2, x1, y1, and just plug those in. Okay, now from here we say 2 minus 2 is 0 squared, plus 8 minus 3 is 5 squared. 0 squared is just 0. 5 squared is 25, so we'd say it's the square root of 25, which we know is 5, so 5 is our radius. Now we know our center, we know our radius, so we are ready to create our equation from that. We would say then x minus 2, because that was this piece, squared, plus y minus 3, that was this one, squared, equals our radius squared. Well, if 5 is r, then r squared equals 5 squared equals 25. So 25 is this piece here. So that would be our equation for the given circle. So now if we have we need to write an equation for a circle that we know the center and we need to find the tangent. So let's plug in what we already know for sure. X minus 3 squared plus y minus 5 squared, and we're just looking for r squared now. Well, let's find exactly where that center is. It's going to be 3 units over and 5 units up. So here is our center, and we know that it lies tangent to the y-axis. So if this is our y-axis right here, and it lies tangent to that, meaning it touches it at one point, but only one point, that means we know our radius is going to be 3 units away. So we could go another 3 units in this direction. We say, here's another point for it. Another 3 units down. Here's another point. Maybe 3 units over. Here's another point. So our circle is going to hit at all of these points. And it's going to look like this. The most important part that we know from this, though, is that the radius right here is 3. Because it's 3 units away from that tangent line, the y-axis. So we can replace this with 3, which, now that we know it's 3 squared, we can actually replace it even more to our final answer of 9. We would say then that this is our final equation for that circle.